I wanted to talk a little bit about something that I also saw on Instagram about plants. Plants being able to communicate. And this is something that if we go back, I mean, almost a year and a half ago, I want to say, I talked about on this show Paul Saladino, and I've talked about him probably multiple times in the past. And I've done a pretty much a 180 shift on him because there are other people that I follow who have exposed his viewpoint as being myopic and being very close-minded. But one of the things that he has said is that there are these defense chemicals that are released by plants, and by doing so, they can harm the person who is ingesting them, and it's a defense mechanism so that they can survive longer, which makes sense. However, I was kind of just taking his word for it and kind of just like, okay. And then with more new evidence, and I've posted about this stuff on my Instagram of people debunking him. Um, but there has been more evidence that has come out now that says basically, and we'll see right here, that these plants are by way of chemicals able to interact and communicate with each other and basically create a network among itself for things such as saying, hey, they're cutting us down today. Hey, there's bugs here. Hey, we have these organisms that are trying to eat us. We need to conserve more water because it's not raining as much. So there's too much sun out. So we really need to start growing. Like this communication network between the plants and the plants. It's very, very cool. And I want to get into this study. So without further ado, let's hop in it. I am very, very interested to get into this story, particularly because I think it's important. I think it's important to understand the way that this particular planet works, because this kind of communication that is done between these organisms is something that since the 1980s has been hypothesized and there has been some evidence for. But now I think we can apply this sort of communication between plants and apply that to, say, a different civilization, say, life outside of Earth. Maybe there is some kind of organism that's on the moons of Jupiter that is able to communicate with each other and interact with each other in a different life form than we would be accustomed to here on Earth. So I think this is a very interesting thing, but let me stop talking. Let's get into this particular article. Let me start off with a video just kind of overviewing the thing. It's only 3 minutes. I'll probably get copyright strike, but that's okay. So, as it's saying, Japanese scientists recorded plants talking to each other, communicating. From Saitama University. I think we've talked about it. This university in the past. They're doing some good stuff over there in Japan. Scientists say plants use fine mist of airborne compounds to talk. We'll get more into this later, but let's just watch the video. Study demonstrates how plants assess and release airborne compounds. These airborne compounds, similar to smells, form a fine mist. That serves as the communication with the plant. So they're sending this mist of these basically chemicals, spreading it around, and that's what they're using to communicate to other plants. Scientists observed an undamaged plant responding to a damaged one. Plants can detect organic compounds from damaged ones. Basically saying, yo, somebody took a bite out of me. I need help. This triggers defense mechanisms to protect themselves from threats. Now, how do they do that? Scientists connected an air pump to a container with leaves. Okay. I'm liking this music. Hopefully, in the YouTube video, this will be able to. The container also had caterpillars feeding on plant leaves, munching away. Plants damaged by caterpillars found talking to undamaged plants, basically like, yo, there's a caterpillar that's eating me. You gotta get out of here. I assume. Biosensor installed revealed undamaged plants receiving messages. Injured plants reportedly send danger cues to undamaged ones. Interesting. All right, now let's get into this article. So as we saw in the video, a team of Japanese researchers made a groundbreaking discovery, capturing real-time footage of plants transmitting defense responses to their neighbors. So the study...
Our last story tonight is about a superpower.
All right. The study's breakthrough lies in observing undamaged plants responding to volatile organic compounds emitted by other plants experiencing mechanical damage or insect attacks. And the insect attacks is what we saw in the video. Then here's a quote: plants perceive volatile organic compounds released by mechanically or herbivore damaged neighboring plants and induce various defense responses. Such interplant communication protects plants from environmental threats, the authors explained. Now, the thing is how they are doing this. Obviously, we saw in the video they're doing this through a mist, but let's learn a little bit more. The experimental setup included an air pump connected to a container of leaves and caterpillars in another chamber housing Arabidopsis thaliana, a common weed from the mustard family. The Arabidopsis plant were genetically engineered to fluoresce green upon detecting calcium ions, which act as stress managers. So they basically created a plant where they were able to see basically how it was communicating, which is very cool. So they had hypothesized that they are communicating. We'll get into it further, that we've kind of had an idea that plants are able to communicate with each other since the 80s. That's what I said when we started. But in this exact study, they actually went through and created a plant where they could detect how it was communicating to the other plants around it. Using a fluorescent microscope, the team could monitor the signals released by the undamaged plants after they received VOCs from the damaged plants. All right, and here we go, coming up next. This study builds on initial observations of plant communications documented in 1983, which sparked significant discussion within the scientific community. Quote, we have finally unveiled the intricate story of when, where, and how plants respond to airborne warning message from their threatened neighbors. He emphasized the crucial role of this unseen communication network in alerting neighboring plants to imminent threats in a timely manner. In summary, Toyota's research shines a spotlight on the complex and subtle interactions with the plant kingdom, within the plant kingdom, while broadening our understanding of ecological relationships and plant defense mechanisms. So you have a plant that's being eaten, and it sends out these VOCs, as we look up here, volatile organic compounds that are emitted by other plants experiencing damage or attacks. So they're sending out these signals to the other plants. And like in the video, we saw it as kind of a mist, but it's these chemicals that land on the other plants, and then they're able to somehow decode that information and know that there are other plants in the area that are under distress, under duress. And then as a result, they're able to take preventative measures to help save themselves. Now, what that is, we have to figure that out. As discussed above, the world of plant communication is a realm where chemical signals, light messaging, electrical impulses, and networked roots create a complex language that is crucial for plant survival and interaction. There was somebody on the Joe Rogan Experience, I think Paul Stamets, who talked about the largest organism on the face of the earth is actually a mushroom. And what happens is this mushroom on the surface is just the little caps that you know. But underneath the ground, the roots of these mushrooms, and this is spanning thousands of feet, and it takes up basically square miles, is how big this actually becomes and gets. And through the roots, they're all different parts of the mushroom are able to interact with each other, shift, and share resources along different parts of the roots. So this is something that we've had some knowledge of, but we do not have direct evidence like we do now with this particular study. And I think it's interesting because I have plants in this room right here, and I've had plants that have died. I have plants that I have forgotten to water for maybe a week or two, and then they start to die a little bit. What signals are being passed along from plant to plant? I have an aloe plant and I have a basil plant, among other plants, but those are the only two that I know the name of. If one of those plants is being eaten by, say, a fly or a caterpillar gets inside and it starts eating it, is that able to send out a signal to a different type of plant? Or is there a language barrier between the different plants? I don't know. And I don't know if that's something that was answered in this study either. I do have the full study that we will briefly touch on, but it's a lot of jargon that I do not understand and I'm not qualified to speak on. But is there a certain language, like say basil speaks Spanish and aloe plants speak French? Is that kind of what it's like? Or is there an ability that if a basil plant is somehow being harmed by any which way, is it able to send a signal over to a different type of plant, even if its roots are not connected? I'm not sure. At the heart of plant communication lies the use of chemical signals. As discussed previously in this article, plants release a variety of volatile organic compounds into the air, that mist that we saw. VOC serves as messages to neighboring plants. They can convey information about environmental conditions such as drought or pest attacks. For example, when a plant is attacked by herbivores, it emits specific VOCs that can be detected by nearby plants. So this is leading me to believe that in our aloe and basil example, we would have the ability for one plant, say an aloe plant, which I have taken a piece from because I got a really bad sunburn when I was in the Dominican Republic, and my back was all dry and itchy, and I had something that's known as the devil's itch or hell's itch, which was one of the worst experiences of my life. Definitely do not recommend you to not reapply your sunscreen. Just flat out, just stay out of the sun if you are of a similar complexion to myself. It's just sometimes not worth it. But I took a piece of the aloe from our aloe plant. Now, when I did that, could there have been a possibility that the aloe plant sent out a signal to the surrounding plants? We have multiple plants right along here. I know it's hard with the sunlight coming right there to be able to see it, but we have other plants on that side of our apartment and over there as well. When I took out that aloe, did the plant send a signal to the basil saying, yo, watch out, there's somebody around here hurting me, or say, like, what does it actually say? I guess we'll have to figure that out. These neighboring plants, upon receiving the signal, may then bolster their own chemical defenses in anticipation of a similar attack. So, in our example, maybe the basil is conserving resources, conserving its water, because it knows at one point it might have to fend off some kind of being or some kind of whatever it may be from trying to eat it. Interesting, interesting, interesting. One of the most fascinating aspects of plant communication is the transmission of alarm signals. When a plant suffers physical damage, it releases VOCs that signal distress. This not only alerts neighboring plants, here we go, to potential dangers, but also attracts natural predators of the pests harming the plant. That's interesting. So if you have a plant in which say in our basil and aloe plant, let's say there's a caterpillar that's eating all of our basil, that basil plant can send out a signal to spider. I don't know what the natural predator of a caterpillar is. I'm not sure, but it can send out a signal to the natural predator of that exact thing that is eating it, that is harming the plant, to have them come find it out. So it's basically calling in reinforcements. Crazy stuff. And then how is that natural predator of whatever is eating it, how does how did they receive these messages? Very, very crazy. Crazy stuff. Yes. And then it says, in essence, plants can call for help, recruiting allies in their fight for survival. Very interesting. And I mean, this probably is tenfold when you have plants that are connected via the roots and they're all one type of plant that's kind of in a garden. And say you have deers that are eating it in the garden, they'll communicate to each other, be like, hey, we need more resources. I got 50% of myself being eaten over here. I need to regrow this. So can you give me some extra water? Can you give me some extra nutrients? Send them over this way. Very cool. Plant also communicate through electrical signals, a method reminiscent of the nervous system in animals. When a plant is stressed or damaged, it generates electrical impulses that travel through its structures. These signals can prompt physiological changes in the plant, such as closing stromata to prevent water loss during drought conditions. So, in our apartment, that's probably happening very frequently because I tend to forget to water them for maybe 2, 3 weeks. I've gone a month or two without watering them. And luckily, we have plants that are able to survive without having water every day. But I would imagine that they're able to communicate to each other, be like, yo, this guy's not giving us any water. I guess we just got to conserve for a little bit. And luckily, they have enough sunlight in certain areas of the house so they're able to survive long enough. But we have had some perish, which is unfortunate, but I just am not on top of the watering. Beneath the soil, plants engage in a complex form of communication through their roots and associated fungal networks, often termed the wood wide web. This network is primarily focused by mycorrhizae fungi, which connects the roots of different plants. Through these connections, plants can share nutrients, water, and information. For instance, a plant experiencing nutrient deficiency can receive supplies from a neighboring plant throughout this underground network. This symbiotic relationship not only facilitates communication, but also fosters a supportive plant community. Okay. Understanding plant communication is crucial for appreciating the dynamics of ecosystems. It helps explain how plant communities respond to environmental challenges. In summary, boo, boo, boo. All right, now let's go to the actual study. So here is the study. You see all the authors right here. I'll post this down in the description. And like I said, I'm not going to really read too much of it, but you can kind of see right here. This is a image of um here. Now that we know what VOCs are. So it'll go from air pump, flow meter, goes into here. This sends out the VOCs that it's damaged, sends out signals to this receiver and this little dish, this little plant right there, and they're able to detect that. And you can see right here, if you look at L1 on this top row, this first frame is 0 seconds. Second frame is this 600 seconds? What's that? 6 minutes? I don't know. And then this other one, 1200. Is that 12 minutes? Not doing the best at math right now. But anyways, this shows you the lighting up. If you look at this top part, you can see where this arrow is pointed, this yellow arrow. You can see that in the first slide, there is no light on that top portion of the plant right there. And then after 600, we'll say seconds, it's lit up. And then add another 600 seconds, and now it's even more lit up. And you can do the same for the different extremities of this particular plant. You look at the bottom right here, pretty dark. Then in the next one, it gets a little brighter. And then in the next one, it gets a little brighter. Same thing for this one over here on the right. This one is the most difference probably of any of these. You see right there, it's almost completely dark, the same color as the background almost. Then it gets a little bit more green, and then it gets even more green where it looks like it's glowing. And then same thing here for the bottom. And I do assume that these are seconds because I don't know how fast the communication is going to be, whether that's inside the plant itself, sending signals from, say, the tip of the plant is being eaten. How long does it take for it to send a signal? Oh, crap, I'm getting eaten by a caterpillar up here. I need extra resources. We got to reach out to all of our people to let them know that I'm in danger. How long does that take? It looks maybe it could be 10, 15, 20 minutes or so, which is interesting to think about. I wonder if it could be faster, if it could be slower. Does it depend on the type of plant, where it's from, whether it's communicating through the mist as we saw, or if it's communicating through the roots? Which way is actually faster? And we'll continue right here. You can see more images of the actual lighting up of the plants. A lot more stuff right here. More stuff right here. This is really cool because you can actually see the signals going through the plant, which is really cool to see. Whole bunch of mumbo jumbo, a lot of graphs and stuff that I cannot figure out. Interesting stuff. Now, let's take this idea of plants being able to communicate and look outwards. I've talked about many times on the podcast about Europa, which outside of Earth appears to be the best place for life in our solar system. It's very cold. However, under its surface, because of the core of that particular moon, it is warm enough theoretically to have liquid water under the surface. It's a layer of ice, about a couple miles thick. It's pretty thick ice, but then underneath that, there is what they believe is liquid water. And they're able to see that because there are some vents that go through the surface, and we're able to detect and look at what is in those gusts of water, or those geysers, and see what the contents of that are. Now, This type of communication between plants is something that since the 80s we have kind of known about, is the word that I'll use. Is there a different type of communication? And I've talked about this before, but is there a type of communication where, say, a different civilization is trying to get in contact with us? Last episode, I talked about Oumuamua, the asteroid that came from outside of our solar system and passed by Earth. Was that a signal? Was that a sign? Was that some form of communication from a different civilization, possibly millions or billions of years ago, letting us know about something and we just don't have the capability of interpreting that message? How likely is that scenario? A scenario where we are being constantly bombarded with messages of stay safe, this is about to happen, be careful of this, do not fight in wars, do not do all of these horrible things that us humans on this planet are capable and quite often doing. Are those signals being sent out? And if so, are we able to interpret them? Are we able to listen to them? And are we able to react to them? Because the signals that we're sending out, we've been sending out radio signals and in different kind of forms of electromagnetic radiation out into the universe in order to connect with other civilizations. Are we on the wrong frequency? Are we not communicating in a way that can be observed and can be understood by other civilizations? Not every world out there is going to speak English. Perhaps no planet out there speaks English. No planet out there speaks any of the languages that we here on Earth speak. And that creates a whole list of problems as well. We don't have this network of plants where all the plants share this common knowledge of a particular language. Like I said with the basil and the aloe, does one speak Spanish and one speak French? It appears not. But in the case of humans, it appears that we might be speaking French and the aliens are speaking Spanish. And I don't know. I do hope that doing more research on this and kind of understanding one, how the root system works, how they're able to communicate through the roots of their entire colony to say, all right, I need more resources on this particular plant because of droughts and this particular plant because of animals that are fighting them. Also through the physiological processes where they have something eating it and it sends an electrical signal to another piece of the plant to make them aware. And then we obviously have the mist that is basically being emitted by these plants, which is also used to communicate as well. Could these very same things be applied to us humans with far out civilizations? I think it's likely. Obviously, the roots one wouldn't work, but is there a certain kind of mist that we could spread out through the universe that could be understood, that could be encoded, that could be interpreted by a different civilization? I sure hope so. And I know one of the things that I talk about very basically every single episode on this podcast, and the reason why I do is because I think it's important and I genuinely think about this question every single day is, are we alone? And if we're not alone, what if we're sending out the wrong message? What if they're receiving the messages, but they don't know what they say? And there's wisdom that these other civilizations that are, say, even 1,000 years more advanced than us want to be able to help us out as a civilization, but they can't because they can't see what we're saying, or we can't see what they're saying. I don't know. Maybe one day we'll be able to have the plants of our civilization connect to the plants of another. And through that process, those plants could talk to each other. Say there's a aloe plant here on Earth. Could there potentially be another aloe plant on a different planet? I don't see why not. Could they potentially, if close enough, interact with each other, and then us as two different civilizations encode those messages in our own language? Would then we be able to send messages between plants and communicate through that way? I'm not sure, but I don't think Google Translate is going to help anybody.